Thank you all for coming. My name is Brad Topal. I'm IBM's Distinguished Engineer for Open Technologies and Developer Advocacy. I'm a Kube contributor, also made contributions to OpenTelemetry, and I'm a SIGDoc maintainer for Kubernetes, and I'm also led the SIGDocs localization work group, although I just stepped down from that activity, so I'm emeritus there. But thank you all for coming today. I'm going to hear it talked about keeping an eye on your cloud-native applications with OpenTelemetry. So why is this important? Well, cloud-native applications, they're complex. You got a lot of microservices. You're hopping across multiple nodes. And, the big questions that you're going to typically encounter, why is something happening? Why am I hitting performance bottlenecks? Why am I hitting points of failure? Maybe I'm seeing unexpected behavior. Where in this processing across all these multi-tiered application did the failure occur? Where did the bug occur? And so observation techniques such as metrics collection and distributed tracing can help us understand what's happening in our cloud-native application. So let's talk about the challenge of observability. I'm guessing a lot of you out there, you write in whatever application you like, right? So how many people write in Go, right? A lot of Go. How many people write in Java? A lot of Java. How about JavaScript? Python, right? So turns out all of you out there are using different languages, right? And if we're going to do observability, we've got to instrument those languages. And turns out there's a lot of tools out there that if we can get everything instrumented, there's a lot of tools for visualizing, whether it's the tracing or the metrics. I've only shown 3 up here. I think it's Grafana at the top. I know it's a little hard to see, and there's Instana in the middle, and there's Zipkin at the bottom. But if you look at the world here, right, we got to worry about getting all these applications written in all these different languages instrumented, right? Because if you got a multi-tier application, maybe it hits one application in one language and goes across to another application in another language. And if we want to worry about distributed tracing, we got to worry about all that. And then you pick a visualization tool, and so you create the instrumentation tailored for a particular visualization tool, and then you decide, well, that's not the right tool. And now I got to change everything, right? That's not a happy world, right? That's not a happy world at all, and it caused a lot of challenges and a lot of frustration. All those different trace formats, all those different metrics formats, all those different back-end tools, and all those different languages we need to worry about. So let's look at the solution to observability. The one that's really coming today is the de facto standard, OpenTelemetry. Okay? It's an open source observability framework, and it's going to support distributed tracing, metrics, log collection, and it's got a whole bunch of folks working on instrumentation for all these popular languages, right? So every one of these languages, there's a whole bunch of folks working on instrumentation, and we'll get more into the instrumentation. Sometimes it's automatic, which is great. You can get things automatically instrumented and injected. Sometimes it's manual. We'll talk about it. But this is going to be the solution going forward, OpenTelemetry. And so what is it? It's a high-quality, ubiquitous, portable telemetry that enables effective observability. And again, it's going to give you your traces, your metrics, your logs. It's got drop-in instrumentation. It's going to work with a lot of popular frameworks. So, whether it's Spring or ASP.NET or Express. And it's open source and it's vendor neutral, right? So it's open source and it's vendor neutral. And you can get started today with it. So if you're not familiar with OpenTelemetry, it's a CNCF, a Cloud Native Computing Foundation sponsored open source project. It was the classic Reese's peanut butter cup, right? You had chocolate over here, you had peanut butter over here. Why don't we put them together? And that's what happened. There were two previous projects. One was called Open Tracing and one was called Open Census. Both projects for observability had advantages. They both covered different areas. And isn't it nice when open source people get together and say, oh, let's all work together. We'll create a new project, right? So that's what they did with OpenTelemetry. And it's experiencing explosive growth. So you can see, 2020 at 1,400 contributors and 110,000 contributions. And in 2022, you got 5,300 contributors, 450,000 contributions. And the nice thing is all your big vendors have hopped on board of this idea of having an open telemetry framework and being able to share pieces of that framework instead of everybody building a proprietary one. And so there's, developers from over 500 companies have contributed. I don't know if you all can read this, it's a little small, but there's top contributing companies out there. I don't know if the ones you might want to see, I'll point a few out just for fun. But there's Splunk, there's Microsoft, there's Amazon, Datadog, International Business Machines, Instana. Large number, and if I didn't mention your favorite one, my apologies, but when I attend these meetings of the open source community, really great representation from a large number of vendors. And so again, if we're going to talk about the features, right? It's open source, it's a standardized based approach, it's going to give you a single consistent instrumentation layer, it supports all your favorite languages, and it's supporting all the big ones. Distributed trace, metric, log data. It's going to support exporting the data into multiple backend formats. So why is that beneficial? We'll talk more about it, but you can then support multiple backend observability tools, or if you're the person generating the instrumentation, generating the trace or the metrics, you can generate it in one format and not worry about who's going to absorb it down the line and present it. So why is that good? We're in an open source conference, no vendor lock-in, right? It's easy to send the same instrumentation to a different vendor's tool. So you can start out with one vendor's tool, maybe it's my vendor's tool, and maybe, unfortunately that's not doing it for me. Very easy in this framework to switch over to a different vendor's tool. Well, that's very important. So again, it's going to show how we instrument things in a vendor-agnostic way. We'll get more into that. And then again, you can analyze all that data with the backend tool of your choice, and there's lots of them out there: Prometheus, Jaeger, Zipkin. Pick your favorite. So we'll get into a little bit of the architecture of the observability framework. But what's going to happen is you've got an application, and two ways you can go about it. Through the SDK, you can end up generating what's called OTLP. That's their standard format data. We'll talk a little bit more about that in a second. Or, you've got things that generate native data, and you don't want to change it, native telemetry data. So those are sort of your two paths that the framework is going to support. The OpenTelemetry community works on the OpenTelemetry protocol. And again, this is a general purpose telemetry data delivery protocol. It's designed in the scope of the OpenTelemetry project, and it's going to define your data format. It's going to define your encodings, your transports. And so it's giving you a mechanism to transmit and deliver that telemetry data between the different sources. And there could be intermediate nodes before you eventually get to the back ends. It's a really flexible architecture we'll talk about. But again, if you're curious about the details, the data format is protobuf. People familiar with protobuf, right? Serializing this stuff up. The encodings are binary, and JSON I think is really new. I think it's still on the experimental side, but it is supporting JSON. And your transports are HTTP and gRPC. There's a couple different deployment options. We'll talk about the top three. First one is a deployment option is the OpenTelemetry with an observability backend, and it's using an agent. And the good example of this one is with the Java language. The Java language, the team's been working on an agent, And it's really nice because when you have those bytecode languages, you can actually do injection or insertion of the instrumentation. That means more, less work for you and I. And so, again, you look at the approach that will support either the proprietary data or the OTLP common format. You can go through the agent and go from the agent to, say, directly to a back end. So that's a pretty simple approach. That's one deployment option that you might see. Another one, they call it serverless typically, is even simpler, where the application is just, say, generating the OTLP and going straight to a back end. Pretty basic deployment option number 2. And if we want to look behind door number 3, here things get a little more complex, right? Here's where we're using one of the main components of the OpenTelemetry framework. They have what's called a collector. And so here you've got maybe one application on this host and another application on this host. And again, maybe this one's generating the new desired common format in OTLP. Maybe this one's still generating a proprietary trace format or metrics format. But then they can get into the collector, and from the collector, and we'll talk about how it's able to do this, from the collector then it can then send the proprietary formats to multiple backends. So we showed pictures showing different graphical visualization or analysis tools. So this is a very popular format, and then you can fan this out for scalability. So you've got nodes in the middle here that can handle more and more of the collection. So let's dig into the details of this a little bit more. Again, if you look at the OpenTelemetry collector, if you look on the left here, you got your application and it's instrumented. And inside, there's 3 main components of this collector. And we're going to talk more about them. There's receivers, there's processors, and there's exporters. And then from the exporter, we can go back to the back ends. Here's a little more detailed picture of that same architecture. Again, content could be coming in different formats. And it gets received, it gets processed, and then it can be exported out into different formats as well. And what you do with this collector is you have a configuration file. And I've showed a very simple one on the right here. The configuration file here that you see, it's going to tell you what receivers it has and what protocols they support. And then it's got a processors. And again, we're going to talk more about what a receiver, a processor, and an exporter is. But the exporter here that we're going to be using is generating content for a graphical tool that's built by Instana. That's going to be your observability backend. The content coming in this case is OTLP. And there's a processor. The one that we're using is called batch, and we'll talk about what that means in a minute. And then we can just configure it to create pipelines of our receivers, processors, and exporters. And so why this is useful is you're going to see there's a ton of different receivers, and there's a ton of different exporters, and there's a certain number of processors, and you can use these configuration files to wire them up any way you want to get the desired observability framework that you want. So let's look at that first main component. What's a receiver? A receiver is a component that gets data into the collector. Okay, and the data could come in as HTTP, gRPC. The receiver is going to accept the data in a specified format, and it's going to translate it to an internal format, and that's what it's going to pass on to the next phase of the pipeline, which is the processors and exporters. And so sometimes the receivers use a push model, sometimes they use a pull model, and they support different what are called signals. That's that fancy term for catch-all for traces, metrics, logs, and some context information they call baggage. But the receivers support one or more of those data sources. And if you go to this GitHub site here, you can go see that there's a large number of these receivers that can receive data, right? So let's just go through, we've got some time. There's one for Cloud Foundry, there's one for Docker Stats, there's TCP, UDP, so you got low-level system-level stuff. And then if you're into Kubernetes, right, you got the K8s cluster receiver and K8s events receiver. Even the lower, there's Postgres, RabbitMQ. So a lot of people are doing a lot of work, and that's the beauty of when we get the open source community together to go work on a common solution, right? Now everybody can start contributing their little piece to the world, and you start seeing a lot of these receivers being available to everyone to use. And again, we talk about it's going to get everything to a common format, then we go from a common format, and we'll see that we can get things exported to a whole bunch of observability tools. So what is the processor step? We've talked about the receiver receiving the data in and massaging it to an internal format. But the processor is there is due to processing, and it's think buffering, think batching, think all the things you have to deal with when a whole bunch of trace data comes flooding in, right? So there's a batch processor, and it's an accept the content and batch them up, so it kind of does some buffering. There's a memory limiter processor that worries about making sure that you don't run out of memory, and if it needs to, it'll drop some data or invoke garbage collection. So, and there's actually a large number of processors for processing the data. I'd like to say I know what all these are, for and what they do, but there's you can go check out the website here and go see what all these different processors do. Again, I've shown the two main one, which is batch and memory limiter. What's an exporter? This is where things get fun, right? So an exporter is a component that's going to, worry about reformatting from the internal format to whatever is the proprietary format needed by the observability backend. So the exporter is the component that sends data to one or more backends or destinations. Common backends, excuse me, Jaeger, Zipkin, Prometheus, and Stana. There's a large number of these. So if I didn't mention your favorite one, let's go look over here on the right. There's a lot of AWS ones, a lot of Alibaba, Jaeger, LogZO. So I tried to do a fair job of representing everything that's in there. There's Tanzu. Again, the power of the community working together, agreeing on a common framework, agreeing on a common transport, and then they can all plug in their custom exporter. And so, as a vendor, why is this great? Because if, everybody starts using the OpenTelemetry framework, and then they come up with a better observability tool, they can say, keep doing everything that you're doing and just plug in my exporter at the end, and everything else in your world gets to stay the same. And that's the power of an open source community working on a standardized approach. So again, let's talk about the instrumentation, because that's the key here, right? There are folks working on instrumentation for all these languages. So there's Ruby, there's Erlang, there's .NET, C#, Go, Python, Java, JavaScript, PHP, Ruby, Swift. Wonderful communities that are all working on these. And again, some languages are a little bit better. They have frameworks where, like I said, a lot of cases, if you get lucky, you're going to get that auto instrumentation, right? It knows what to instrument in your framework. It knows what your calls you're making in the framework. You don't need to, do much at all. And then there's some languages, where maybe you got to do manual instrumentation. Go, for example. And I'm going to actually go through a Go example so we can all learn about how this works. But ideally, if you got the auto instrumentation, it's a little better. And so just look at some very simple definitions here. Traces, right? This is a record of path of a request that's going through multi-tier architectures. And what's nice is it worries as you hop on different nodes, there's W3 standards for what are called keeping track of your context. So you can kind of understand the context of a request going through multiple hops. And that's built into all the OpenTelemetry client instrumentation. They call it a context. And your trace is made up of what are called spans, which are one or more units of work. And again, it's going to represent the entire journey of the request through all nodes through the distributed system. So you get a lot of information out of your traces. Metrics, hopefully a little bit easier to understand. The metrics of the service captured at runtime. You've got CPU usage, it's a classic one, memory usage, number of active requests. So you've got different types of metrics. And then logs are just timestamped text records that might be structured or unstructured. So, let's have some fun and go look at a simplified tracing example for a simplified, very simple Go program, just so we can get a feel for what this looks like in the real. So we're going to go through different pieces of code here, but this is a a very simple program to poll the user for, give me a number, and based on that number, I'm going to calculate the Fibonacci number for that request, right? And so, the first piece of the code is the run method. And inside of it, there's a poll method that we'll get to where it'll poll for that number, and then based on that, it'll go compute Fibonacci. But here we can see these are the actual, this is a Go language. We can actually see the commands we're using here to be able to create a trace and create a span in the trace. So I didn't show it here, but you wanted to show you create a context, and your different subparts of your trace can use the same context. But then, we've got a label for the span, right? So this is going to be the run span. And each piece of your code that does some work should be represented as a span. And then each section of the loop, we should get a new root span and context so we can kind of get a flow for all this trace that's being created. We can end the span when we're done. If we go to the next one here. Inside of the hey, we're going to ask you what Fibonacci number would you like to know, and we scan for the input here, and that's the polling step. So we're going to call that context the polling context. So we can create, again, a new span and part of the same trace, and this is the poll context. And then we defer it at the end, so that's when the trace will end. And then here's a little nice feature. So they picked a number, they entered it, and we can set an attribute in the trace, and we can take that number that they picked and put it in the trace. So what did we learn? Important attributes can be stored in the trace as well. And we've got the different spans that are labeled. And then as we get into this incredibly complex code that took me 3 years to write, we'll go into the Fibonacci here, the write method, right? So here we're going to have a subspan. So the Fibonacci is inside of the write span. So it's like a child span is what we call this. So these new spans can be nested inside of other spans. And if we look, it's going to say, hey, we run the Fibonacci here, and that's going to be labeled there. And then at the end, we're going to write. But this ends up being a subspan of the write. And let's go look at what these look like. So if we look at a simplified tracing example, again, here's the code. And then here is sort of the trace that's generated into sort of, and again, remember, we can export this trace in any format we want. The one that I picked was a simple human readable format, right? So I picked a human readable format. And you can just see the simple values here, right? So the trace has a trace ID, so we can see the trace, goes across all the different spans. You've got your trace, for the name of your span is poll. And then you also get to say what your parent was, so you know what the parent span was. And then remember, we had a set attribute method here. The number I typed in, I guess, was 5. And so, you can even include attributes. But this is the whole piece of the trace that's in a sort of a human readable format. And again, it's going to be an intermediate format in the tool and can be exported to every trace observability tool you can think of, right? So if we go to the next example, now we've got the example with the nested spans, and then here's what they look like, right? So the child span was the Fibonacci span, and then if you go look at its span ID is going to match the parent. So the span ID for its parent is actually going to match the span ID for the write, and that's how you're able to figure out that Fibonacci was a sort of a child span of write. That's the magic there that they keep track of knowing those things. So if we get to the summary here, again, it's OpenTelemetry. It's an open source-based observability framework. We can use it to instrument, generate, collect, and export telemetry data. It's got a single consistent instrumentation layer. It's going to support multiple languages. It supports the generation and collection of trace, metric, and log data. You can instrument your application in a standard vendor-agnostic way. And it's going to support exporting that data into all your favorite observability tools. So there's going to be no vendor lock-in for you. And you can easily send that instrumentation to different vendors' tools or to multiple vendors' tools. So that's what I have here, and if you want to come see me, I'm going to head soon to the booth. I do have a book that we've given out free copies of. It doesn't really cover observability, but it's hybrid cloud app, so it's kind of close. So it's OpenShift and Kubernetes. So please feel free to come by the booth at 3:30. After I'm done with this, I'm going to hustle on over there and get a free signed copy of the book. So thank you very much.